Hello, everyone. Welcome to this session, Production Ready Flink and Hive Integration. My name is Bowen Li. I am a committer at Flink. And today I'm glad to walk you through what stories you can tell with this Flink and Hive integration and what kind of use cases is opening up for the audience. Okay, and during this pandemic thing, I hope everyone is staying safe and healthy. I watched like a few folks yesterday in the Flink Forward virtual sessions wearing hat, and I thought I had one. So why not wearing it, right? Let's make it a tradition of the virtual conference. So yeah, I hope you guys enjoy the session today. And at the very end, I'm gonna bring up some bonus materials. So stay till the end. And we also have a Q&A at the end, about 5 to 10 minutes, okay? So here's the agenda today. I will briefly walk through the background of this effort. We will look at what's the status quo of Flink 1.10, which is released about 2 months ago. And we will look at the upcoming features in Flink 1.11, which is going to be released in the next couple months or so, and look into the detailed use cases and stories. So as a background, you may have heard it many times that Apache Flink is a framework, a stream processing, stateful stream processing framework over unbounded and bounded data streams. And when we say unbounded, it means streaming, and bounded is actually batch, because you know the full data set, when where it's located, how much what's the volume of it, when it start, when it end, all that, right? So Flink has this philosophy from the very beginning that batch is a special use case of streaming. So we announced Flink and Hive integration as beta in Flink 1.9 with a few goals in mind. First, we want to help all the businesses that are right now in the batch world or like more latency world to move and shift to a more real-time fashion, to be able to really leverage Flink's real-time power and get more real-time insights to bring real value. When we say like data is all value, but also the value is in the timeliness of the data, right? So if business can leverage more real-time power, we believe this gonna empower them to do more things and opening up all the use cases and scenarios. We want to build Flink's cutting-edge streaming capabilities to batch. In 1.9, we brought in Blink Planner, which is much more powerful than the legacy planner. And in 1.10, we finished about, I would say, 90% of it. So we really want to leverage this planner's capabilities to adapt streaming strengths to the batch world. We also want to help companies to unify their infrastructure and tech stack. Over the years, originating from the Lambda architecture and the beginning of the big data world, infrastructure has becoming increasingly fragmented over the years. Just for the online and offline data infrastructure, you may already have a few of each to do some of the job, right? And we want to kind of unify them together, so you have a much more simplified deployments, and also lower cost of operations and maintenance. At the end, I think is we want to bring a much smoother experience to the end users. For example, developers, data engineers, scientists, analysts, all that. We want to lower the bar for them to enter the streaming and the big data world, right? To really enable them to do self-service and learn a little bit less fragmented syntax, even though their functionalities may be the same. Just focus on a few infrastructure to be really able to leverage those. State of Union of 1.10. So let's take a look at the features that are already available on the market for you right now, as comparison to the Flink 1.9. Unified metadata management. So over the years, Hive Metastore or HMS has become the de facto metadata hub of the Hadoop world, right? I even actually see many companies that, all their infrastructure are in the public cloud, but they are still using the Hive Metastore as the single source of truth to manage all their metadata, both Hive and non-Hive, both cloud and non-cloud, or self-managed. So Hive Metastore really become the center of the metadata management. So we introduced Hive catalog back in 1.9, and in 1.10 we make it production ready. Okay, in 1.10 is right now compatible with almost all the versions of HMS. There are two folds of the Hive catalog here. The first one is user, as mentioned in the background, user is not able to store their Flink metadata in the Hive Metastore. Okay, so they can have a central place to manage not only to manage all the other infrastructure metadata as well as Flinks. The second fold is that Flink will be able to leverage Hive catalog to read and write Hive's own metadata. So Flink can, read and write Hive data based on that. So now I will walk you through an example, an end-to-end example of Hive catalog. Okay, what we're gonna do is we're gonna create a Flink Kafka table and store it in Hive catalog into HMS. And then we will be able to retrieve it later and actually query the table, the Kafka table in Flink without having to, write any DDLs. So first, so we will do this in Flink SQL client. Okay, so first we will configure the Hive catalog in the CLI's YAML file. So you can see here at the execution phase, I select, I set it to be blank planner in streaming mode, and I'm gonna use my Hive, the catalog at the current catalog. Okay, and then in the catalog section, we create Hive catalog based on all these configurations. Name with my Hive, type is Hive. We specify the Hive conf directory, and based on that, the Hive catalog will be able to figure out things like the location of the Hive Metastore, the user and password, the version of the Hive Metastore, and be able to spin up a corresponding version in Flink. So once we we make the Flink SQL CLI up and running, we create the Kafka table. The Kafka table has two fields, name and age. and with a bunch of properties that you would normally do. Okay, once you create that, let's switch to Hive CLI and take a look at what's over there, right? So you can see here, we log into the Hive CLI. Then we see, hey, describe formatted my Kafka table, right? And you will see what's actually stored, Flink stores in the HMS, what it pulls over there. And you can see here that the Flink table has been serialized into a bunch of properties in Hive tables parameters fields as just key value pairs. For example, the servers, the connect, the topic, the type. This is exactly the properties that you type in Flink DDL, right? And at the bottom 4 lines, you could see the schema of the table, which is like you can see the names of the field. You can see the types over there. I think there's a formatting issue. For example, at the last second line, the data type and the int should be like separated, but there might be a formatting issue here. Then we switch back to Flink SQL CLI and say, right now we select star from my Kafka table. Okay, what it does is Flink right now will the planner will go through Hive catalog into the HMS to retrieve the table and convert it back to a Flink table that the planner can understand and use that for spinning up queries. So you can see that, with this example, if you shut down Flink and the Flink SQL CLI and you restart it, the my Kafka table will still gonna be available for you over there, and you don't need to write any DDL anymore. So this is this kind of metadata persistent feature really helps Flink users to manage their ever increasing metadata. We are supporting much more high versions in 1.10. So in 1.10, we covers almost all the high versions, including all the 1.x, 2.x, and 3.1. We believe this probably covers 95 or more % of the customer and the user base over there. Oops. In Flink 1.10, we introduced the feature to reuse all the Hive UDFs. Okay, we think this really helps the user to avoid any pain and extra efforts during the migration. UDFs are usually the most customized and development intensive thing in a SQL system. It has lots of the custom logic accumulated, right? And during migration, we don't want users to be, to be required to rewrite all those stuff. So reusing Hive functions is a very big win for our users. And in 1.10, we extend that compatibility to all the Hive built-in functions. Why? Because if you compare the built-in function, the richness of the built-in functions between Flink and Hive, you will see there is a big gap over there, right? Flink probably just have a tens of few built-in functions, while Hive, I look at Hive 3.1, it has almost like 400 built-in functions. So those functions are super handy to the users, right? They are built for a purpose. So instead of requiring Flink users to rewrite and port all those functions, wouldn't it be nice to make those Hive built-in functions available to our users, right? So the compatibility with Hive built-in function is supported through a new mechanism introduced in Flink 1.10 called module. Okay, so the module API is targeting at extend the Flink SQL's core system. For example, the data types, more functions, and all that. Some of the concrete examples we think of is that, is already in the horizon is that we can support more geo and machine learning data types through the module API. And we implemented everything through a module called Hive module. On the reading side, Flink 1.9 can read non-partition or regular and partition Hive tables. In 1.10, we are extending that to Hive views. And also when you are reading ORC files, you can, we are by default using the vectorized reader, the native reader, so the performance is much better. We also introduced optimizations like partition pruning, projection pushdown, and limit pushdown to really trying to limit the data that we sort from the disk and travels over the network to Flink to increase the performance. On the writing side, Flink 1.9 can write only regular Hive tables. In 1.10, you'll be able to write to partition tables, both static and dynamic partition. And we support an insert overwrite syntax. So what's coming in Flink 1.11, right? It's just like probably 1 month left to be feature phrase, and we are super excited to bring it to the audience. First, the biggest request we received so far is Hive near real-time streaming sync, right? You want right now all the Hive read and write is all the Hive write is only done on the batch mode of the Flink planner. Okay, so users usually want to have Flink streaming data directly into Hive. So we are introducing this thing. It's gonna be based on the streaming file sync of the data stream API. So to bring a little bit more real-time experience to Hive. We are introducing native Parquet reader, just similar to the vectorized reader of ORCs for better performance. Better interoperability, right? How cool is that if you can create Hive native tables, views, and functions within Flink, right? In that case, you wouldn't need actually to switch back to Hive CLI anymore. You can do everything in Flink SQL. Better out-of-box dependency management. Oh my God. If you have ever tried to deal with Hive dependencies, you know it's messy. It's a total mess over there. So we are fully aware of that. You know, one of the biggest pain we saw so far is when users start to use this Flink-Hive integration and they are so upset about the Hive dependency configurations. Yes, we know and we follow up. So we are building some, we have prepackaged all the Hive dependencies, just trying to into some, distributions and provide those, package files out of box for you to leverage. And, when users usually run Hive jobs, they are actually doing it through some JDBC drivers or gateways, right? And we are introducing a Flink native JDBC driver and gateway in 1.11 so that you can reuse all your existing tools to be able to submit and run SQL jobs. And a little bit more Hive syntax, so stay tuned on the details. So what exact story or use cases does this feature enables you to do? I would just introduce a few ones as an example, all right? So story one, you can have a finally unified compute infrastructure. So you can have Flink to process both the online streams as well as the, historical storage data in the storage in Hive, and leverage Flink as a single unified compute infrastructure to produce results. And right now you can, you usually have the requirements that, when you process some online data on the fly, you want to join it with some historical data to be able to, bring in more knowledge and context, right? So right now you can both ingest Hive and the online data into Flink to be able to do the join via temporal table joins, making Hive tables as a changelog temporal table. But there's watch out that this would be only recommended if the Hive table size is okay, all right? Because Flink, depending on your specific logic, Flink gonna store your historical data in Flink state. So if it's too huge, then it's gonna go out of the boundaries and stress Flink out. But I will talk about like how to solve this problem later, all right? Story three, you can do more, flexible backfill on demand and on Flink failures. Okay, you usually have this pipeline, for example, data coming into Kafka. You have Flink listening to the Kafka queue, the Kafka topic, process the data on the fly, and you will also streaming the the raw data into some distributed file system like X3 and make it available as the the raw data source for any later processing, right? So what happens if, say, your business logic change, right? You need to update your Flink jobs. And also at the same time, what about all this historical data? You need to reprocess them. The second case is, what if the Flink job is down for some reasons? I shouldn't say fail, probably down, during migration, upgrade, or it's actually, failed for some reasons. And when you bring back the Flink cluster, you need to reprocess some of the data that has been missing, in the downtime, right? What can you do? So in the past, you would write a second Hive job to do that, right? You would basically copy all the logic in Flink to Hive job and do the backfill. But with 1.10, it's not necessary anymore. You can use the same job and same piece of code to process historical data on demand, and no need to maintain a Hive job. So here's some interesting observations we saw that, because when you see like a Flink restart, you would normally think, hey, why don't you use Flink to reprocess the data that has been missing in the pipeline, right? Basically rewind to the last successful checkpoint and resume from there. We see lots of users not doing that because, it's been quite a few downtimes over there, and they just don't want to have Flink process those piled up data to further increase their pipeline latency and sacrifice their SLAs. So they would rather just have Flink process at the latest position of the Kafka topics and have some second job do the backfill. Lastly, this is an upcoming feature that you can finally have a near real-time data ingestion into Hive, right? So I think this is all. And in the next few slides, I'm gonna bring in a few bonus content, okay? So let's say in the the last story, we are bringing near real-time data ingestion into Hive. You see, like, is this too good to be true, or is there any cost or limits that is hidden behind the thing? So before answering that question, I want to just have a quick poll. Yeah, is that I want to ask everyone: do you feel your traditional data warehouse or data lake, any data lake, any data warehouse, that is really a good fit for streaming native engines like Flink? Is your data warehouse and data lake keeping up with the speed of Flink? Or do you have to do any, tricky questions that you have to deal with when integrating this? Okay, there's a poll over there. It'd be nice if you guys can, submit your answers. And of course, Hive, the answer of Hive is, way beyond other options, because this is a session for Hive, right? All right. So if you feel that pain, when integrating Flink with your data warehouse and data lake, you are not alone, okay? There's many people over there, and we all attend this session because of the pain, right? And we want to remove that from your day-to-day operations. So I will just bring up a few unsolved problem of, integrating Flink with any data warehouse or any traditional data warehouse or data lake on the market. Okay. So first example is that how do you what if you want to join the real-time data with huge amount of historical data, right? In the previous slides, we said that temporal change log table is not very good for huge amount of historical data. So how do you solve this problem? Well, you may say that, hey, I want to probably not importing any data from Hive into Flink, but just do a point lookup, right? Where when we process data in Flink, we make some kind of queries RPC through RPC or JDBC to Hive, and just get the specific information that we need back to Flink. While traditional data warehouse and data lake, don't really support point lookup, right? They only do scan. They are for OLAP. They only do scan. And you would say, hey, what about bringing any some other infrastructures like Cassandra, HBase, Redis, or whatever other like key value store or cache layer to this job? Well, congratulations, you are going quite the opposite direction, actually completely opposite direction of unification, right? The purpose of unification, by diligently adding one additional infrastructure at a time to our big data landscape. So how do we really solve this problem? The second example of the unsolved problem is, well, does the, if we use the near real-time sync from Flink to, stream data into Hive every 5 to 10 minutes, is there a limit? Can we do better? Let's say 1 minute, every 1 minute? And what's the cost it implies, right? I would argue that in practice, it's not possible realistically to go, to a lower latency than 5 to 10 minutes, because they're gonna just bring in too much small files to your distributed file system and Hive, right? Because of that, you are the end-to-end latency of your real-time pipeline is basically capped by the interval that Flink commits the files in your distributed file system, right? For example, in the normal pipeline, you will have, just I would say second level latency from Kafka to Flink, that part, right? And then you will have like at least 5 to 10 minutes latency on the Hive part. So is this really what you want? Anything that you saved upfront in the Kafka and the Flink world is going to be wasted, totally wasted. There's no meaning of making your Kafka and the Flink cluster to be super high performant in this case, because there is always a 5 or 10 minutes, latency over there waiting for you, which is, several hundred probably magnitude larger than the latency of Kafka and Flink. So so it's meaningless. And even if you commit every 5 to 10 minutes, come on, there's still a lot of files, daily basis. So how do you, handle all this, fragmented small files? Maybe commit, enlarge the commit interval to 1 hour. Well, how dare you call it a near real time in this case? If you have a 1 hour delay, come on, this is Flink forward. 1 hour latency is not acceptable. It's no way near real time. All right. Or you say, hey, I still commit at every 5 to 10 minutes, and I have an Airflow hourly job to merge them into an hourly file, and on a daily basis merge it again to a huge daily file. Well, isn't this going back to the batch world again? What's the point, right? So how do we solve these problems? Is there a solution for this? Yes. And, as a bonus, I'm glad to announce that we are launching a new purpose-built product called Holograph. Okay. So if you want to learn the exact information about why we build Holograph, except from the 2 examples I bring up, on the unsolved problems, there are still many more problems that we want to solve with Holograph, as well as how we build Holograph, what's the architecture of it, okay, what's the philosophy of it. Check out the very next session right after this session, okay? Right after this session in room 5. It's presented by Xiaowei Jiang. It's called Data Warehouse, Data Lakes, What's Next? Okay, so I think it's a very visionary product. And internally, we have been using it very, very extensively to replace the, any traditional data warehouse and data lakes. So I think this would be a super, super useful session for you. Watch that session and, give us some feedbacks. Ping me on LinkedIn, on Twitter, or just email me directly, at bli@apache.org. So I'll be happy to catch up and to see if our product can help your team, your use cases, your company to achieve more. And spend less time dealing with these frustrations between Flink and traditional data warehouse and data lakes. All right. So conclusion. Flink 1.10 brings production-ready integration between Flink and Hive on both metadata and data sides. So we already, from 1.9, we already have several big customers using it, kept on giving us feedbacks. So we are making it production ready in 1.10 now, with all the feedbacks and bug fixes and features, okay, to fill the gaps. And there are still some unsolved challenges in this thing. And we're gonna see the next generation of big data storage and analytics product, emerging and get attention. So watch the next session. Okay, by Xiaowei Jiang. Okay, thanks. So I guess I'll take some questions. And yeah, if you want to follow up with me, or just get informed on what's going on with Flink and Hive and Flink and other data warehouse and data lakes, follow me on Twitter. All right.